This is question number 1 from the Test 2 Quick Check. And in this question, we're being asked to use implicit differentiation to find y prime, where y is a function of x. So since we're told to use implicit differentiation, that means we need to take the derivative using the equation as it's written. We're not going to rearrange or do any algebra before we start the calculus. So we need to rewrite x cubed plus 2 times x times y equals 5e to the y power, and take the derivative of each of these terms as it's written. And as we're taking the derivative, we're going to keep in mind that x is an input variable. So when we see an x prime, we can cash it in for a 1 because the derivative of a plain variable is just 1. And when we see a y is a function, so y prime will not cash in for a 1. We'll just record the derivative of y as y prime. Okay, so let's take the derivative of each of these terms. Let's start with x cubed. I'm going to do my power rule. So I'll bring my 3 down to the front. I'll rewrite the base. I'll decrease the exponent by 1, and then I'll tack on the derivative of the base. But in this case, that x is a plain variable, so the derivative of x is just going to be 1. Now moving on to the next term. The next term is interesting here, y'all. The next term has a 2x side by side multiplying with a y. So we're going to need to use product rule when we take this derivative. Okay, so I'm going to do some side work over here. So my first term was a 2x, and my second term was a y. So when I take the derivative of the first, since x is acting like a plain variable, the derivative of 2x is just 2. But if you want to do the power rule, you can. There's an understood 1 exponent on base x. I drop the exponent down to the front, so 2 times 1 is 2. I rewrite the base. I decrease the exponent by 1, and then I tack on the derivative of the base. But x to the 0 power is going to be 1, and x prime is also going to be 1, so the derivative of the first term is just 2. And then looking at the second term, when I take the derivative of y, it's just going to be recorded as y prime, and y is a function, so it does not cash in for a 1. So let's go ahead and put all of that into our product rule. I'm going to shrink this down real quick so I can have some more room here. Okay, so here we go. Product rule. We have our first, which was 2x, times derivative of the second, which was a y, so y prime, plus the second, which was y, times the derivative of the first, which we saw was a 2. And I don't need to put that in parentheses because it's being added, and when I distribute addition, it doesn't change the signs of the terms. But if you want to put it in parentheses just to be safe, you can. If that had been a subtraction right there instead of addition, you would have had to put it in parentheses because subtracting the terms does change the sign of each term. But it was addition, so I'm not going to include those parentheses. Okay, so now I need to take the derivative of the other side of the equation. On the other side of the equation, I have 5e to the y power. Okay, so I'm going to need to use the base e rule. With chain rule. So here's the base e rule. The base e rule says if you have a base e with a functional exponent, then the derivative of that is base e to the functional exponent. You just rewrite exactly what you saw there, but then you tack on the derivative of that exponent. So I'm going to use that rule here. And if there's a coefficient in front of your base e, it just goes along for the ride. And here I have a coefficient of 5 in front of my base e. So it's just going to carry down into my derivative. So when I take the derivative of 5e to the y, it's just 5e to the y. But then I have to tack on the derivative of that exponent. So that's y prime. Okay, so let's go ahead and clean this up because it's quite a mess right now. So in this first group, since x prime was a 1, I'm just going to have a 3x squared plus, in this next group, there's really nothing I can do. I'll just write 2xy prime plus, in the third group, I'm just going to change the order of the multiplication and write that as 2y equals, again, in this last group on the other side of the equal sign, there's not much to do. I'll write 5e to the y prime But we're supposed to be finding y prime, so we're not done yet. Right now I see that there's a y prime on the right side of my equation and a y prime on the left side of my equation. So I need to get those on the same side of the equation. I'll just go ahead and subtract the 2xy prime from both sides. So this is just algebra. We're not doing calculus right now. So that'll leave me a 3x squared plus 2y on the left, and I'll have a 5e to the y prime minus 2xy prime on the right. Again, I need to isolate that y prime. It's still in 2 locations, so I'm going to factor it out. I'm going to factor out a y prime. So when I do that, that's going to leave me with a 5e to the y in the first group minus a 2x in the second group. Now that I have y prime in one location, since that y prime is being multiplied by this binomial, I'll just divide both sides by that binomial. So let's go ahead and do that. So I'll divide by 5e to the y minus 2x. Other side, I'll divide by 5e to the y minus 2x. This will divide to 1, and I get my y prime. My y prime is just equal to this fractional amount. Were we told to, no, we weren't told to evaluate that derivative for a certain x and y value, so we're done. We found the derivative of y implicitly.